Okay. All right, first thing I want you to do is I want you to pick up your calculators, okay? Now, do you remember how to do shading on your calculator? Okay,
Tell us.
I thought I did, but I might not have. If not, I'm going to tell you right now, okay? Let's say you have this that you're supposed to, and I tell you to graph it on your calculator, okay? Go ahead and go to y equals on your calculator. So you're going to have y equals, right here, it says y sub 1. Okay, go ahead and put your x plus 2 in there. And then over here on the left-hand side, if you use your arrow to go all the way over on the left-hand side. Hold on one second, let me clear this. Okay, you'll see that you've got like that line, like that. Do you see that? Okay, so go ahead and put your cursor over top of that. Okay, so that that's blinking. That's what you should have, is blinking. Okay, you're gonna hit enter on that, okay? When you hit enter the first time, you get a wider line, like a fat line, okay? If you were to graph it with that, it'll show a really fat line on your graph. Okay, then the next thing you have is like this. Right? Okay, I want you to think of that as an arrow pointing up. This is your greater than sign. Okay, so for this one, that's what I want. So go ahead and have it blinking on that. Okay, select, you don't even have to select that. If you use your right hand arrow and go over it, will stay on that. Now graph it. Hit graph.
Y2?
No, just hit graph.
Just leave that.
Oh, yeah, clear that. Oh, shoot. Oh, yeah, it did have both of them in there. Okay, come on. Okay, so if you just graph that, it will shade for you. Now you can shade yours in different colors, like if you put a couple things, because what we're going to do today is we're going to be putting more than one inequality on our graph. And we're going to find like the corners of their bounded region. What we're about to do is go into something that's called linear programming. Now, we're not going to get hot and heavy into linear programming, but you're going to get a taste for it. Linear programming is used mostly in economics, where you want to like maximize your profit and minimize your work, okay? And so you are trying to find things that will allow you, equations that will allow you to figure out, okay, how much of this product do I need to make, and how much of this product do I need to make in order to maximize my profit, okay? That being said, what you're going to do is you're going to graph several things on your graph at the same time. Now, I'm going to pull out the colored pencils because it is very helpful if you will do a different equation in each color, and you will write that equation in that same color. Okay, now you've got an advantage because this is where all those colors on the calculator come in. So, but you're still going to have to do it by hand because again, I said, you can't just imprint your calculator on your paper. So, all right, so let me put some color pencils out there and I'll show you what I'm talking about here. This is when we find out that the tables are not level. As I said. Obviously it leans this direction. Okay. For instance, now sometimes you don't have any points of intersection. Sometimes you have two parallel lines and they're shaded in opposite directions, so there's nothing in common. But most of the time what you're going to be looking to find, oh, and I didn't tell you, okay, this is your greater than, okay? If you think of it as like you have a box and that part is shaded, this is your greater than. If the other part is shaded, the down part, so that like you can make a down arrow, that's your less than. And you find it in the same location on your y equals, okay? Let's say I have this. I'm gonna have to go back and think about absolute values again. Okay. I've got, well, I should say I've actually got 4 of these, because remember this is written like x is less than 3 and x is greater than negative 3. Okay, remember how that's 2 different things? Okay, so that being the case, okay, let's graph this. All right. I've got x is less than 3, so I'm going to remember that's a vertical line through 3. Now I am not going to shade it right here. I'm just going to keep the shading in my mind, because if you shaded all of this, it becomes kind of a mess on the graph, okay? And you want to be able to see the bounded region. So right now, what I'm talking about is less than the 3, so I'm talking this way, okay? Then I'm going to turn around, and since it's very similar, I'll go ahead and do that in the same color. This is x is equal to negative 3, and it's this way. Now, the truth of the matter is, both of those are dotted, but that's not extremely important on this. Okay, so right now we're in the center, okay? So then I go on and I graph this one. So I have negative 2. I'm going to go up 1 and over to the right one, and I'm going to draw that graph. Okay, I'm going to go ahead and put my equation next to it, but I don't put the inequalities. Okay, it says greater than that. So now I'm up here. Okay, you with me so far? Okay, got one more. Now I'm going to graph this one. 1, 2, 3, 4. I'm going to go down 1 and over to the right 2. So I have y equals negative 1/2 x plus 4. Okay, and it's less than, so here's that. Okay, now it's a little bit, and that's what I kind of thought, these actually cross, and without the benefit of graph paper, you don't see this, because this actually crosses inside this. Okay, now what that makes the difference in is the fact that I have in my bounded region, I have 1, 2, 3, 4 vertices. Okay, I have 4 corners. That's basically what I'm saying. Well, here's the difficulty. In linear programming, you have to find those vertices. Okay, so that's what we're going to work on at the beginning, and then I'm going to show you what you're going to do with them. Okay, so sometimes they're really easy. Sometimes we can just stick it in our calculator, find the point of intersection. Remember how we did that when we were graphing? The little kicker is I have 2 equations that are x equals. As long as all my equations are y equals, I can put all of them in my calculator. But I can't put the x equals equations in my calculator. The reason why I color code it is this. This right here is the intersection of the red equation and this blue equation. So I take this red equation, now this is x equals negative 3, so I can't put it in my calculator. But what I can do is I can substitute negative 3 in there for my x and solve for y. Because I know the x value on this is negative 3. What I'm looking for is the y. So I go y equals negative 1/2 times negative 3 plus 4. So that's going to give me y is equal to 3 over 2 plus 4. That's 1/2, is it not? So 1/2 plus 4 is 5/2. If I want to, I can just do that, do 5.5. Okay, that's the easiest way to do that. Okay, there's one. Okay, let's do, while we're doing it, let's do this one down here. because this is the intersection of that equation, the y is equal to x minus 2, and that x is equal to negative 3. So now I'm going to do the exact same thing, but I'm using this equation. Okay, now that one we can do in our head, okay? Because I have negative 3 minus 2. What is that?
Negative 5.
Negative 5. So this point down here is negative 3, negative 5. Okay, so there's 1 point, there's 2 points. Now I'm going to find that point and that point. Doing the exact same thing, but this time my x is 3, not negative 3. Okay, you with me? So let's say I plug it into that same equation I did. I have 3 minus 2, and I know my x is equal to 3. What is my y equal to?
1.
1. Okay, girls, you getting it? You understand it? Okay, here is the intersection between x equals 3 and this red line. So it's this equation. I plug in my 3. So this time I have a negative 3 over 2 plus 4, or I have a negative 1.5. So what I have left is 2.5, right? Okay, so y is equal to 2.5. I mean, you can do that on the calculator. So this is the point right here, 3, 2.5. Okay? That's going to be half of your problem. Okay, we're going to work on the first half a few more times, and then I'll show you what you're going to do with those. You're going to take these and you're going to plug them into an equation, and you're going to find a maximum value and you're going to find a minimum value out of it. Okay? So far, so good. Sort of, kind of. Okay, sometimes it's not a bounded region. Sometimes, like maybe you don't have this line right here, and it goes all the way up. You don't have a maximum value on that. Okay, you still have to find a minimum, but you wouldn't have a maximum.
Still find the points.
You still got to find the points. Yep, yep. All right, let's do another one. This one has all y's. So this one's a little bit easier to find the points of intersection. Okay, you with me? You're not with me. Sort of with me. Okay. You have x minus y is less than or equal to 7. 3x minus 11y is greater than or equal to negative 11. And I have x plus y plus 1 is greater than or equal to 0. Okay, so I have 3. Let me make sure I wrote them right. Okay, I have 3 things to graph. Can I graph them like that?
No.
No, I got to put them in the right order. That is probably one of the most important things you can do, because if you don't get them in the right, if you can't rearrange it, you can't graph it. Okay? So on this one, I'm going to take the x over, but then, so when I take the x over, I still have a negative y. So remember, I have to divide through or multiply through by the negative. What do I do when I multiply or divide through by a negative? I got to switch the inequalities. Okay, so that becomes positive and that one becomes negative. Okay, so that is one equation I'm going to graph. Okay, this one, same thing. I have negative 11y is greater than or equal to negative 3x plus negative 11. I've got to divide through by that negative 11. So I switch the direction of the inequality. That becomes 3 over 11x. And that is just positive 1. Okay? So that's my second equation. This one, I've got to take both the x and the 1 over, so I end up with that. Okay? So those are the 3 equations that I'm going to graph. Now, I think you'll actually appreciate those because they have y equals something, and you can let the calculator do all the work. Okay? So I'm going to put them on my graph. Now the calculator's not going to literally put it on the graph for you on on your graph paper, but, all right, so let's graph that first one. I'm gonna go down 7. And then I'll go up 1 and over to the right 1. And I get that right there. Remember to write your equation, that's important. Okay, it's greater than this, so I'm up here. Okay, the next one, I'm gonna go up to 1, and then I'm gonna go up 3, and over to the right 11. So more or less, oh, I didn't go far enough, did I? Okay, these are gonna cross over there. Ooh, not that way. Okay, so I have y is equal to 3 over 11x plus 1. Okay, so then that's less than that. So right now I'm talking about this strip right here. Okay, then the third one is -1, and I'm going to go down 1 and to the right 1. Okay, and it's going to be above that line, so I'm talking about this triangle right here, right? Okay, pick up your calculators, put all 3 of those equations in there. Now you don't have to put the inequality, okay? Don't mess with the inequality, just put them in under y equals. So this is going to be sub 1, this is going to be y sub 2, and this is going to be y sub 3.
And then graph it.
Yeah, you can go ahead and graph it, but we're really not going to use the graph. Okay, once you get them in there, I'm going to show you. It will automatically graph it as we do what we need to do. Okay? Just make sure you've got all of those equations in there. Everybody got all of those equations in there? Okay. This vertice right here is a combination of the blue and the purple. I guess you want to call it purple. So I need to use this and this. So look at your y equals. Obviously the one that I'm not using is this. So over top of your equal, take that off, okay? So in other words, right now, all of your equals are highlighted, but I don't want the x minus 7. So I'm going to move my cursor over top the equal, I'm going to press enter, and it's going to pull it off. Okay? Okay. Got it, Joseph? Okay, now go to second calculate. Select intersection. Remember how we did this? And then keep hitting enter until you get the point of intersection. Did it come out?
Weird decimal.
Is there a weird
That's
decimal?
wrong decimal.
Okay, you can actually, I think the calculator might, how about if we just do 1 point, does everybody got a decimal there? Okay, negative 1.5 and maybe 0.6, okay?
I think I did it right. Was I not supposed to use all 3?
No, you weren't supposed to
Okay.
use all 3. Okay, the one that I don't, see those 2 that are underlined? Those are the 2 that I want. Okay, hold on 1 second, I gotta stop this and restart it.